Hi everyone. Today we are going to see classification of energy storage system. So in previous video we have seen what is energy storage system and why we need energy storage system. But in this video we are going to see about what are the classification of energy storage system. Okay. So first thing, why energy storage is needed now. So one thing is why energy storage is needed. So in main thing is industry challenges or driving demand of energy storage. So now the main thing is demand of energy storage, while policy, technology, and the cost advantages makes it more attractive options. So the main thing is strong demand of energy storage. So demand of energy storage. What are the demands of energy storage system? Is increasing intermittent renewable generations, increasing customers expansions and uh, engagements, and aging infrastructures and regulating transformer from centralized to network grid. So these are the strong demands from industries and increase energy storage adoptions. So by increasing the energy storage abduction and increasing performance at a decreasing price. So we have to increase the performance with low price. It is a policy we have to make in policy initiatives, and we have to find the technologies and performance and advancement, and we have to take the technologies demonstrations and variations. The main thing is cost reductions. So because of these we can overcome the demand of energy storage in industry sites. Okay. So now what can energy storage do for you? So what happens if the energy storage has many applications but one few are relevant to the commercial and industrial needs? Okay. So the main thing is electrical cost and optimization. Electrical cost and optimization. Okay. What is main thing is electrical cost and optimization. So peak of peak price managements, demand of power factors managements, and renewable energy shifting. This comes under energy cost optimizations. And capacity. So generation reserves, example capacity maker and capacity contract operation reserves and demand response programs. These are considered capacity, and transmission distribution infrastructure, and these are comes under the capacity. And routine grid operation is the frequency regulations and voltage VAR support and renewable energy ramping and renewable energy smoothing, and continuous situations, the black start, sustainable outages, and momentary outages. We have to concentrate on these also. Okay. Now, what are the technological options we have? So we have so many technological options. Energy can be storage comes in the many forms. Only some of the practical for practice for commercial and industrial building is we have main four part. So one is mechanically how the energy is stored in the mechanical form. So first happen is we have can store in pumped hydro storage system, pH systems, and compressed air energy storage system, CASC, and flywheel energy storage system. This how the energy is, electrical energy is stored in the form of mechanical energy. Okay. Now next thing is battery. We know that battery, we are already familiar with lead acid batteries, advanced lead acid batteries, and zinc air, sodium sulfate, sodium metal halide, and sodium ion and lithium ion. So in this form we can store the electrical energy into the chemical energy. Okay. Now the battery flows, so zinc bromine, vanadium redox, and ion chromes, and others. So this are stores in the form of flow batteries, and others. So others is now we know the thermal ice base, thermal moderns, and power to gas, and hydrogen. So this is natural gas. It stores in the form of gas. There's the electrical energy stores in the form of gas. And capacity and capacitors, electrical double layer capacitors or super capacitor or ultra super capacitors. So these are stores in the form of other form of energies. So main thing is energy stores in from the mechanical form, and energy stores in a chemical form, and energy stores in the thermal and other flow batteries, chemical forms. So these are the main four part. So now the researchers are main concentrating on these four areas. Okay. Now in this we are today now we are going to see the mechanical storage systems, how the electrical energy stored in the form of mechanical energy, and how it giving converted into again it's converted into electrical energy and giving back to the grid. Okay, so in this today we are going to see the how the energy stored in the mechanical form with the help of flywheel. Okay, so the mechanical energy storage system, so flywheel energy storage system, this is a which a cross section of energy storage, flywheel energy storage systems. Okay, now, so the flywheel energy storage is essentially a mechanical battery. So it is also known as mechanical battery, simply a mass rotation about an axis. So flywheel storage is system mechanically in the form of kinetic energy. So mechanical means we know that we have a kinetic energy. They take an electrical input to accelerate the rotor up to speed by using the built-in motors and return the electric energy by using same as the generator. Here we have motor and generator setup. So it gets the input as an electrical energy. It stores in the form of mechanical energy, and again it converts the mechanical energy to electrical energy. So we need a motor and generator. Motor to convert electrical energy to mechanical energy, and generator to convert mechanical energy to electrical energy. So flywheels are one of the most promising technology for replacing conventional lead acid battery as an energy storage system. Okay. Now, this is a block diagram. Here we have the motor generator setup. This is the bearing. This is the flywheel, the stator, and power converter and control. So power converter, this we converts the AC to DC, DC to AC, whatever may be. This is a general block diagram of flywheel energy storage system. Okay. So here we know that kinetic energy, the main play thing is kinetic because we have a rotational force. So kinetic energy, we know the formula. So kinetic energy is half I the omega square. When I is the moment of inertia and omega is the angular velocity of the rotating disk. So I is r square dm, then the cylindrical the moment of inertia. So I is equal to 1 divided by 2 r power 4 pi ap. So the energy is increased of increasing omega angular speed and increasing of the current. So the energy can be increasing either by the angular speed or angular velocity or by the increasing the current. Okay, I can be increased by locating such as the mass outside of the disk is possible. But as the speed increases, the more mass is located outside of the disk, and the mechanical limitation also is important. Okay, so that now we can see the design of flywheel energy storage system. So flywheel energy storage system the best suited for peak output power of the 100 kVA to 2 megawatts and for duration of 12 seconds to 60 seconds. This energy is present in the wheel for to provide higher power for a shorter duration. The peak output design of our 125 kilowatt for 60 seconds, store enough to provide 2 megawatt for 1 second. So these are the design we have on a vacuum pump. So this is the rotor, this is the motor generator set, axis of rotation, and upper magnet bearings and protecting shield and lower magnetic bearing. Okay. Here we have what are the components. We have a flywheel, motor generator set, and powertronics converters and ball bearings and external inductors. So these are the what are the parts we have in flywheel energy storage system. So how working? It's working main three modes: a charging mode, standby mode, discharging mode. The charging mode is when we convert the electrical energy to mechanical energy. Standby mode is in the mechanical energy. Discharging mode again is convert mechanical energy to electrical energy. So this is what the thing is. A flywheel. We have permanent mode and synchronous motor. So motor generator set. This is external inductors. We have rectifier and inverter. So it converts AC DC DC AC. It's a bilingual. So it's a DC link. And finally, we are having a DC link load. Okay, this is a circuit diagram of flywheel energy storage system. Okay. Here we are the applications where this is load flowing for distributed generators and power qualities and UPS and industry pulse powers and light ray powers and flywheel in distributed networks and hybrid electric vehicles. So in these parts, we are using this flywheel energy storage systems. What are the main advantages is high power density and high energy density, and the lifetime of flywheel is almost independent of the depends on the charge and discharging. The lifetime is also good and no periodic maintenance is required. Short rechargeable time, this is the main thing. And flywheel systems are not sensitive to temperature since they are operating in the vacuum container. So this is not sensitive in temperature. These are the advantages. Okay, and here some of the advantages is you can see compared to other batteries, here the energy density is high in flywheel compared to other type of storage system, compressed air or advanced battery or pumped hydro or lead acid batteries. The energy density system is high. This is the main advantage of flywheel energy storage system. Okay. And that we have a disadvantage, the complexity of durable and low loss bearing, and mechanical stresses are there, and material limits about to 700 m per second trip speed, and its potential hazards, failure mode, and short discharging time. The charge discharging time is short. These are the main disadvantages. So here the future scope, the advanced flywheel system rotates about 20,000 rpm in vacuum, enclosed made from high strength carbons. The flywheels are primarily source of not a primary source of power generation, and rather when there is a too much power on the grid is sent to the flywheel facilities and used to set the flywheel in motion. Then when the power is needed a few seconds or a minute later, the moment of flywheel is used to generate power back to the grid. These are the future work of a flywheel energy storage system. And finally, concluding, that state of charge can be easy by measured since it is given by the rotational velocity. The fast rotation of flywheel rotation is suitable for direct generation of high voltage, the environment friendly materials, and low environment impact. So these are the conclusion of flywheel energy storage system. And with this, we can end this video and hope you will be clear with what is energy storage system and what are the types of energy storage systems and what is mechanical energy storage system and flywheel energy system. Thank you.